Now we're doing FreeCodeCamp Legacy Python for everybody. Networking right a web browser. I'm going to need glasses one of these days. Not today though. And here we are. So let's do it. Boom, like that. And there it is. Oh, well, there we go.
Section, we're going to write a web browser using Python. So we've already got a socket. We know how to write a socket.
Yeah.
In the previous section, we played with.
Hold on. What did you just say to me? We know how to write a socket? What? What are you talking about? Big timer? What are you talking about? Basic process, establish a connection to socket. Okay, well, yeah. Well, where's the... Python has built-in support for TCP sockets. Oh, we put import socket, and then we say my socket equals this stuff. Okay. And then my socket.connect. What the... What is this? Hold on. Do you remember how to do any of this stuff? Application protocol. Okay, well, listen. Maybe we'll get into an actual exercise and he'll show us the ropes. Because right now, I mean, maybe we put this at the beginning. I don't know. I literally don't know. Let's go.
The protocol and use Telnet to do it by hand. And now we're going to do it in Python. And what you're going to find is it's not that hard.
I think PR4E is what we gotta do. I think maybe PY4E is a joke on top of this. Let's go to let's do PR4E. What the fizzle dizzle? What the frizzazzle? What the frizzazzle is this? Let's go to our friend. Hold on. I gotta open over here our buddy. Old chat GPT. Let's go ask our buddy. What's PR4E? Python for everybody. Yeah. Is that what this is? All right. Let's type this down. I don't know what's going on right now. He said we know how to write a socket. I don't know how to write a socket. I don't know where he's getting his information from. But I am not in that camp. I haven't even seen how to write a socket yet. Let's go. An HTTP request in Python. Okay. Whoop. Okay, let's do it. An HTTP request in Python. Okay. We're going to have import socket. So it's going to be one of these. Import socket. We're going to do my socket. Let's get the stuff up here. All right, let's grab this. Come down here. We're going to change it to this 4E, PR4E thing. Drop. Boom. PR4E.org. Let's do it up here too. Turns out, right? What was it? Nope. No. That's simple stuff. Here we are, PR4E. Let's do that here. All right, so there's that. We got that going on right there. Let's see what else we want to do. Oh, this command thing. Command equals get. That sucks. I don't want to type all that. HTTP //data.pr4. We got that part right here. That's a waste of time. Just learn how to type faster, right? For e.org /Romeo .text HTTP 1.0. I forgot what this is, and then we're gonna have two of these. I'm trying to get it to where I've got like my pinky. My pinky does the slash, and then my index finger does the in. Because I bet we're gonna have to do this a lot, the slash in. So get to get into like a rhythm, you know, like a combo. You know what I'm saying? Dot encode. It's not dot encode. You know, and then we'll say my socket dot send command. What? While true. Remember, it's true with a capital because it's Python. While true, we'll do data equals my socket dot RCV 512. What is this? RECV 512. What is that? If Lin, I didn't know we did whatever. If the length of the data is less than 1, we're gonna break it. I'm gonna break out of this thing. All right. And if not, we're gonna print data.decode, whatever that is. All right. And then we're going to say outside of the while loop, my socket dot close. What the hell is this? What is this? Okay. I know what's going on. All right. But what's this? Data. Where did we do that? Data. Oh, it's right above that. Cut, edit that out. You know me. I ain't editing nothing. Okay, I'll start editing hard. Never. Never ever. Never ever. Never ever ever. Ever. Never. All right. That being said, you know, I mean, like once I start making shorter videos again, yeah, I'll start editing. But like these like hour and whatever minute, I am not. No, thank you. All right. So while true, we've got data equals my socket dot receive. What is this? Is this legit? Let's go ask. Is this legit? Let's go ask ChatGPT. What part is the RECV? All right. Let's go ask ChatGPT. I gotta know. I have to know. Is this code legit? Question mark. Boom. That's not all of it. Stop. No, that's not all of it. We're going to redo this whole thing like this. Watch this. Come over here. Why didn't it get all of it? Or did it and I just messed it up? Oh, something was up. Yeah, this is much better. All right, let's go. Boom. My code is almost correct, but there's a typo in the command where it says HTTP. Oh, did I do that? I surely did. I'm glad we ran this through ChatGPT. That's the best way to do things, it seems. Boom. All right. Same thing. Okay. What's the RECV thing? The receive function in Python is used to receive data from a socket. It stands for receive and is part of the socket module in Python. Here's how it works. MySocket.receive buffer size, all right? MySocket, this is the socket object that we've created to connect to a remote server, okay? Buffer size, this specifies the maximum amount of data in bytes that we want to receive in a single call to receive. In our case, it's set to 512, meaning it will attempt to receive up to 512 bytes of data from the server in one go. Okay, great. All right. What happens when we call receive? Receive data, receive function blocks, okay, and waits until what? Until data is available from the remote server, okay. Buffer size, it receives up to buffer size bytes of data at a time. If less data is available, 512 bytes is not a lot of data. It will return the data that is available. And if more data is available, it will receive it in subsequent calls to receive. Return value, it returns the received data as a bytes object. We typically need to decode it into a string, which is why we use data.decode in our code. What? Data as a bytes object. We typically need to decode it into a string. Okay. Interesting. Example. Dang, this thing went all out. I mean, it usually does, but I didn't know it went this far. Example flow in our code. First call, the socket is connected, and we request data from the server. The server responds with chunks of data, in this case, parts of the Romeo.txt file. Okay. Subsequent calls, the while loop continues to call receive 512, receiving chunks of 512 bytes, pardon me, until there's no more data. When no more data is available, receive returns an empty bytes object, which is like less than 1, which breaks the loop. Awesome. Okay, it makes perfect sense, actually. Why receive 5.2 and not a larger or smaller value? I did have that question in mind. 512 bytes is a common choice for buffer size because it's large enough to reduce the number of calls to receive, but small enough to avoid using too much memory at once. Okay. It's adjustable. We can adjust the buffer size based on our needs. Large buffer sizes will read more data per call, while smaller sizes will make more frequent calls to the receive function. In summary, receive. We're going to call this receive. All right, here the last sentence. We're going to call this receive from now. In summary, the receive function allows us to receive data from a server in chunks, which is useful for reading large amounts of data without overloading memory or waiting too long. So I guess it's the optimal size. Okay, great. So now that makes a lot more sense. What the snap is that? I don't know. That makes a lot more sense on the notes and on this. Let me get this out. And on this stuff here, that makes a lot more sense actually. Pardon me, what's going on? So this is where it's going to go data.pr4e.org. Okay, let's go back to ChatGPT. I got another question for you. Does every website have a data.website thing going on with it? The data subdomain we see in data.pr4e.org is a specific choice made by the owner of that website. Subdomains like this can be used for various purposes, but they are not a universal feature of all websites. What is a subdomain? Domains are parts of a larger domain, of course. For example, in data.pr4e.org, the subdomain is data. The main domain is this, and .org is the top level domain. Okay, whatever. Website owners can create subdomains for different sections or services of their site. For example, some websites use www, API, blog, data, data.pr4e.org. Okay, so what does pr4e.org use? Why does it use a data subdomain? Okay, in the case of this, the subdomain data might be used to separate data resources from other parts of the site, like tutorials or course material, okay? Making it easier to organize content. This is specific to this website, and not every website uses such a structure, okay? Can other websites have subdomains like this? Yeah, whatever. Okay, I don't care anymore. Let's come back over here to this, and let's open up the notes again and see if there's anything else, because this feels like it's pretty important, and it's good to understand all this crap. All right, so in the command, why are we doing this? Like, yeah, of course we could watch the video and get that, but I would rather get it on our own and then listen to him talk about it. You know what I'm saying? I'd rather do that. I mean, even though you're watching a video of me doing it, this is the long way, right? We're doing it together, right? That's what this is. It's doing it together, right? Going on a journey, buddies forever. Anyway, so let's go. Hey, Sergeant Riley, what's going on? So let's go over here, and we're going to do. What are we gonna do? I want to know what that's for. What the in is for. So let's go like this. Let's come over here. Let's say what are the 2 line breaks for? In an HTTP request line, headers, provide additional information about the request, such as host, blah, blah, blah. Blank line signals the end of the header section, body optional. In a simple GET request, there's typically no body, so the request ends after the header section, which is followed by 2 new line characters. Okay. The first line break ends the request line, and the second line break signals the end of the headers. Since we aren't sending any additional headers, in this case, Since we aren't sending any additional headers in this case, the doubled new line indicates the request is complete. Okay, so this would be, what? This would be here no matter what for the end of the headers, okay? And this one, pardon me, ends the request line. I guess it's just some holdover stuff that you gotta do no matter what when you're doing this encode thing, this get thing, I should say. And then the dot encode. And then the dot encode. The encode method in our code is used to convert the strings into bytes, which is necessary because socket communication in Python typically requires data to be sent as bytes, not as plain string. Why encode, huh? Yes, why? Sockets require bytes. When sending data over a network using sockets, the data must be in bytes. This is because lower level network protocols like TCP and IP operate on bytes, not higher level data types like string. I believe it. Okay. So converting the string to bytes in Python, a string like this is a sequence of characters, of course, but for the socket to transmit it, we need to convert that string into a sequence of bytes using encode. Yeah, that's why we're doing it, right? Default encoding. By default, encode uses UTF-8 encoding, which is standard for web communications, and converts each character of the string into its corresponding byte representation. Okay. For example, we've got this, all right? This line converts the HTTP request string into byte sequence that can be transmitted over the socket. Okay, before encoding the string this, after, the bytes might look something like this. B. The B ... notation shows that this is now a bytes object. This format is suitable for sending over the network using the socket.send method. Yeah, it's not going to type out all the zeros for the capital G and all the zeros and ones for the capital E. It's not going to do that. Although I kind of wanted it to. I kind of wanted to see some 64-bit action going on right here in real time. At least like 3, characters worth. That would have been nice. Why is encoding necessary? Human readable versus machine readable. Strings are human readable and intended for high-level interaction. We're the high level. While bytes are machine readable and required for lower-level networking tasks. True. We have never gone over the actual bytes, right? Like the zeros and the ones, the cards. How did they used to do it back in the old days with the punch cards, right? We haven't ever gone over that. And I think that we should at some point. Decoding on the receiving end. Similarly, when we receive data from the socket, this thing, the data comes in as bytes, and we need to decode it back into a string using the decode method to make it human readable again. Okay, great. So in summary, the encode is crucial for converting the human readable strings into bytes so that it can be sent over the socket. Makes perfect sense now that we look at it. All right, so I think that might be pretty much all the crazy stuff that's going on here. We went over this part the other day. I forgot what it was. I think it's just the protocol is 1.0. There's also 2.0 and a different one or something like that. We should go over this too, what this garbage is, but later. Okay, here's this too. We didn't even look at this. Our program, socket, connect, send, receive. Socket, connect, send, receive, socket, port 80, and then it goes to the website. Okay, let's watch it. 16 seconds in, it's a 23-minute video. Welcome to the Codeman S channel.
So here we go. So the first 3 lines of this program, import socket, make the socket. Remember, the socket isn't really got the connection. So when you make the socket, again, we're going to make a stream-based socket, and it's suitable for going across the internet. The connection, it's like ring, phone call, connect to data.pr4e.org and port 80. And so that basically says extend the socket across and connect to a web server. And so there's got to be a piece of software running, and this will blow up if the software is not running. Okay? So then, now we've got a phone. We've made a phone call. Now, whether or not the remote side says hello or not is up to the application protocol. And in this case, the web servers say nothing, and they wait for you to talk first. So we're the web browser in this case, and so we're going to talk first. And we know what, because we read the documentation, we know that we're going to send get blah, 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 space, blah, 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 HT1, and then 2 new lines. Return, return. Remember, you had to have a blank line. We'll talk a little bit about this encode. It's preparing the data to go across the internet. And then we say send it. And so this basically takes that little string and sends it across the network. And then this piece of software is waiting for it. And then the software goes and reads a file or does some other stuff. And then it starts sending us data back, which we can then choose to receive. So now I write a real simple loop. we're going to receive these things 512 characters at a time. So we're going to loop through receiving 512 each time. And if we get 0 characters, that means it's end of the stream. The stream is closed. And if you look at the little example from the previous one, you saw connection closed. When the connection is closed, we get an indication that it is because we ask for some data and we get 0 data. Otherwise, if there might be more data, this will wait. If the network is slow, you'll see, if you do a print statement in here, you will see that this will pause from time to time on a really slow network. If your network is fast, it'll just go blank and it'll be so fast it won't matter. But this is how we go. So this is basically until the entire socket, until the socket is closed, we're going to read this data. And because this data is coming from the outside world, we have to decode it before we print it. And then when we're all done, we break out of here and we close the socket. So literally, that is an entire web browser written in 10 lines of Python. And again, this is why everybody loves Python. So this is what this program will show if you run. The get is sent. It looks exactly like doing it by hand. You get some headers. Again, this is metadata that tells you something about the file. In this case, one of the important things is what kind of thing is coming next. There's always a blank line as a break between the headers and the actual data, the metadata and the data. And then here is the actual text of that romeo.txt file. And then it's going to run this, going to print data.decode. All this is coming from the print statement. If you were going to parse this, you have to know that you're going to read the headers up to a blank line. The blank line is your indication as a software developer that the headers have stopped and the actual text begins, and you know the syntax. This actually could be a JPEG or a PNG or some kind of image, right? And this data would here look like blah. So if you type this and you change that code to actually go retrieve a JPEG URL, gibberish will come out, okay? And so that's exactly what you will see. And so now you have built a very simple web browser. Next, I want to talk a little bit about what happens when characters transition from outside your computer, from inside the computer in strings, out across these sockets to servers and then back.
What? What kind of crap was that? You know what I'm saying? Number one, why would you call that a web browser when this is a web browser? You know what I'm saying? Why would you call that a web browser? That, it's that kind of stuff. It's that kind of stuff right there. It's that kind of stuff right there. It drives me insane. All right. I don't know what the hell he's talking about, this being a web browser. What is this? So this, what is this? This is the metadata that comes back. This is so stupid. Is there a website dedicated to being what's the word? Used as an example for this stuff? Like one I can send a request to and get the same meta stuff, the same results. Yes, there are testing, experimenting with this stuff. Okay, I don't like that one. It's too hard to say. Oh, HTTP bin. Yeah, too hard to say. What else we got? Example.com. That's what I like. Example.com. What would we get though? And how would we get it? So do we have to like, I'm about to explode somewhat. Okay. So what do? Do we like put this into, like there's with these people, I don't think they know they're doing it. that they're leaving out these very important steps, and we're just like, what the hell? How did we get to this point? You know, did we write is this a program right here? Did we come over here and we make a new one? Is that what's going on here? You know what? We're gonna use example.com. We're gonna use example.com from here on. What the H? All right. "31 minutes." But we're done with that video. But the thing is, that video is garbage. All right, sure. All right, so this example code. So that example code, we'd put it in the text editor, then save it, then call it with the command line? Question mark? Yes, that's exactly right. Okay. Okay. Let's do that. Let's go to VS Code and do that then. This is trash. I mean, it's trash, but they don't know it's trash. That's what you can't blame these people. You cannot blame these people. They don't know it's trash. They don't know what they're doing. That's all I mean, look, you can't blame a person for not knowing what they're doing. That's, you know what I'm saying? At least they're doing something they're doing something. They're trying something, right? Let's make a new one. Let's make it just inside of this 9, I guess. And let's call it file new. No, that's not what we'll do this. Let's call it example web request .py. Boom. Example web request.py. That's great. All right. So what we want to do here is put that example web request. Let's use the ChatGPT one because it's cooler. Way cooler. All right. So this is just like the one we typed up in the notes, except for this is better because it's not going to, what's his name's website? It's going to something we can actually test. All right, so let's say save it. Boom. Let's open this up in File Explorer. Come over to the command line. Let's say tab. Nope. Tab. Nope. Tab. Nope. Tab. Yes. Let's go home. Python. Come on now. Python. And run it. And what did it do? It gave us some stuff. All right. Look, it went and did something. Look at that. That's cool, huh? We made it do something. Where did it start? Where did it start? What is this? How does it say my stuff? Hold on. Where's the beginning? Where's where I started writing? Oh, right here. Okay. So this is it. Yeah. And it went this HTTP 1. Okay. 200. Okay. I don't know what that means. I like this though. Age. What if we run it twice? Will it give us a different age? Age. Oh, it is very different age. Look at that. This age and that age, there's two different ages. There. What happened? Where are we? Okay, well, here's this one. Where's the second one? Oh, here's this one. Where's the other one? Age. There's age. There's C right there. Okay, cool. All right. Yeah. That's 6 digits. That's 6 digits. And this one's 5 digits. What's up with that? Cache control. Cache control? Cache control? What is all this jobbly jubilee jubity jube that we're getting here? What is all this stuff? Content type, HTML, text HTML, yeah. Character set, UTF-8, yeah. I know what we know about that. Date, that's today. That's not the time. GMT must be Greenwich Mean Time. It's already 1 o'clock, 1:30 over there. Oh, to be in the future, right? E-tag, what's this? Don't know. Expires the 20th of September. 7 days from now, this expires. Last modified 5 years ago, almost at this time in the morning. So it was like midnight where I am. Server ECACC dad bleh. Very accept encoding. Okay. Xcache hit. What does that mean? I don't know. Content length. Okay. Connection close. Awesome. Doc type HTML head title example domain meta characters UTF-8 meta blah 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 body a link body does it? It's like, would it give us the scripts if there were scripts? That's the question I've always wondered. Will it give us the scripts if there's scripts? If like they're using fancy ass, if they're using a fancy JavaScript, right? And I'm like, whoa, that's some nice JavaScript, right? Is there a way to like look at it so that we can find out if that's some fancy JavaScript? You know what I'm saying? Because this, I mean, clearly this example.com isn't going to have any JavaScript on it. Maybe we could check somewhere. I don't know. We'll leave that to another video, but this is very interesting. We're getting close. I can see why Zuckerberg and the other guys broke off from college, because after a while, once you start to get it, you're like, well, these guys in college aren't going to teach me anything but what they want me to learn. And, you know, this is so vast. Why would I want to do that? Why would I do what they want when I could do what I want, right? Anyway, so there's that. Let's go back to the video. Where was it? Right here. That's not even the video. We were already done with the video. So let's go to the question. So what does the following code create? This creates a web browser, right? A simple web browser, right? Because that's what we just did. I mean, there it is right there. But yeah, there we go. Let's check the answer. There we go, and submit it. All right, so now we're on to networking text processing, and we'll see you next time.